So Fisher's sign test left hand, the amount of money in a person's bank account is planned to decrease after Valentine's Day. So we collect a sample, six people, before, after. If you have identical amounts, what should we do? If we have the exact same amount, what should we do before we start the test? Eliminate that observation, because then the test is based on positive, negative signs. So we want to verify the claim using alpha 0.1. So the null is theta equals 0. Alternative theta less than 0. I want to perform a left tail test. So the reasonable way for me to define the difference, should it be after minus before, or is it before minus after?
Before minus after. I think after minus before is more clear.
We are trying to see the negative effect, right? So we are trying to see if things in fact decrease. So in other words, if the after is smaller than before, then you would get a negative, right? We want to see how far you go toward the negative side. So the way to define should be after minus before. So there is nothing wrong in doing before minus after, but in this case, we want to do after minus before, because if we get a negative, if we go to the left-hand side, how far we go toward the left-hand side? Do we make a significant move so that we conclude that in fact bank accounts decrease after Valentine's Day? So we want to find if there is an effect or not. We're doing after minus before. You know, since this is a sign test, even though I did it, you know, by subtracting a null, I wanted to show the difference between a Wilcoxon sign rank test and a Fisher sign test. Wilcoxon sign rank, I would want to know the exact magnitude, correct? Fisher sign test, I don't care about the magnitude. All I need to know is the sign. After minus before, I don't care what value that is, positive. So 1, 1, positive, negative, 0, 1 and 1 minus 3, 12, 0, 5, 12 minus 6, 24, 0, 0. Yes? If this were to be Wilcoxon sign rank test, the magnitude will matter to me. Since this is Fisher sign, it doesn't matter at all. So if I sum all psi i's, I will get 2. So the test statistic is 2. This is a left tail test. So the rejection region will be on the left-hand side. We will reject if the test statistic is less than or equal to the critical value. So since this is an exact test, we know the exact null distribution, which is binomial. N in this case is 6. P always 1/2, because under the null, we expect to have positive and negative signs, 50-50 proportion. So start number 1, since we have n is equal to 6, the possible values are 0, 1, 2, 3, 4, 5, 6. List 2, we have to do binomial PDF. n, which is 6. Under the null, the value of p is 50%, so 0.5. X values are in list 1, so second 1, close paren, enter. Those are the values that we get. So should I look at the right-hand side, left-hand side? Doesn't matter because things are symmetric here. But for the purposes of understanding, since this is a left tail test, we should start from the left-hand side. So I start at 0, the value happens to be 0.01563. When I go to 1, I need to add the probabilities. At the moment I add 0.05163 to 0.09375, I am going to exceed 0.1. I'm going to exceed the value of alpha that I set. So a critical value at a 0.1 level is simply 0. But the actual alpha that we achieved is 0.01563. Write it as 0.016. Yes, so the value that we were looking for was 0.1. We ended up with 0.016. So the test statistic is 2. So based on the small sample that we have, can we conclude that bank accounts decrease after Valentine's Day? No, we cannot reject the null because it has to be 0 or less. Obviously, we cannot go below 0. Had this been 0, sure, not the case. So we do not reject the null, which would mean theta is 0. How did we define our difference? We defined it as after minus before. If after minus before is equal to 0, that would imply after is equal to before. So not a significant effect. Does that make sense? How do we find the p-value? Left tail test, area below the test statistic. So we've got to add probabilities less than or equal to got to be precise here because this is a discrete distribution. So less than or equal to the test statistic. So if we add 0.01593 plus 0.09375 plus 0.2348, what do we get? Point 36.
Point 34.
34.
Yeah.
343 exactly.
Or 3.
You're rounded.
I can remember.
It's 0.01593 or is it 63?
Yeah, it's 63, that's right.
Ah. So it's 0.343.
76.
7. Okay. Let's get 4 decimal places. So the p-value obviously is bigger than alpha of 0.1, so we should not be rejecting null. Does that make sense? So to find the large sample approximation, we need to find the standardized test statistic, which is T minus mu divided by sigma. T is the actual test statistic, which is 2. Mu for a Fisher sign test is n over 2. In this case, n is 6 over 2. We get 3. The variance is n over 4. That would be 3. Excuse me, 6 over 4 will reduce to 3 over 2. That is 1.5. So 2 minus 3 divided by square root of 1.5. Don't forget the square root, very important. So negative 1 divided by square root of 1.5. Negative 0.0, is it 8? 3.
I got negative 0.8164,
Yeah,
or if you round it, 6.5.
Yes, correct. 8165.
Yeah.
Okay, so zero is in the middle. Why should the rejection region be? Should it be on the right or the left?
What?
Left. So we want to find that critical value. That has to be negative. So inverse norm, the area below the critical value under the curve, that area is alpha, which in our case is 0.01. So 0.01.
It's 0.1.
Oh, 0.1. Okay, so that would be negative 1.2, right? 2.8. So it's negative 1.28. So the critical value is negative 1.28. The test statistic is negative 0.816, which is right here. Should we reject the null? No, the test statistic does not fall in the rejection region, so we don't reject the null. If we, yes,
Quick question, just to clarification, when you did the bar sample statistic on the other one, you used the complement 0.5 based on that. Is there a reason you don't do that on that?
because over there it was on the right hand.
So you do a complement on the right tail.
Yes.
On the left tail, you use the actual output.
Yes, because by default the calculator always takes the area below. Right, in the previous problem, the area above was 0.05.
Oh.
So the area below would be 0.95. So the next step is to find the p-value. How do we find the p-value?
Normal CDF.
We simply use normal CDF. Where should we start? We start at negative infinity because it is the area below the test statistic, and the reason for that is the same left-hand test. So negative E99, the value of the test statistic, negative 0.816. The mean is always 0, standard deviation always 1. We end up getting .2070. The actual p-value was 0.3437. Here, it's 0.2073. You can see just from this picture that sure, we're getting close to rejection, but it's just not good enough for us to reject and conclude that the bank account in fact decreases. Perhaps had I observed 10 people, and if the pattern was very similar, then we would have rejected. But based on the evidence that I provided you, there is no significant effect. Does that make sense?